So in this problem, I want to give you a rationale for the answer and how we work through it, because this problem can be kind of tricky. So we're told that a black ball moving at 9.1 meters a second contacts a white ball going 0 meters a second. The white ball then begins to move 7.1 meters a second. So we are asked, find the fractional kinetic energy loss due to the collision. Basically what that says is, okay, the black ball is exerting kinetic energy on the white ball. It contacts, exerts some amount of kinetic energy. Some of it's lost to heat and sound, and then it converts that energy into the white ball and it begins to move. So we go from 9.1 meters a second to 7.1 meters a second. So we are asked to find that fractional kinetic energy loss. Let's go ahead and do that. What is the initial kinetic energy of the black ball? Well, it is, we're going to set up an equation here that Ke equals 1/2 mass velocity squared. We don't know the mass, but we're told that the two balls are the same mass in the problem. So we can assume, and when we do this here, mass is not going to be a terribly bad factor. Mass is held constant, so it's not the end of the world, right? It's a Newton meter over a Newton meter. So if the mass is held constant, given that it's not a factor in calculating Newton meters, and they cancel out anyways, so there's just a ratio of like x to y, right? There's no units. It's just some value compared to another value. It's a ratio. So the kinetic energy, let's find the initial kinetic energy of the black ball. That's going to be 1/2 mass. Velocity is 9.1 meters a second. Square that value, and we get that initial kinetic energy. And we're going to get that that's equal to 41.4 meters squared seconds to the negative second times mass. Okay, so this is a Newton meter just without the mass component factored into it. All right, so that's kinetic energy initial of black. Now let's find the final kinetic energy, right? So we convert all that kinetic energy to move the white ball. What is that? Well, it's going to be 1/2 mass velocity squared, so 7.1 squared. That's going to give us 7.1 squared. We're going to get 25.2 meters squared per second squared times mass, right? So these really are a Newton meter. They're just spelt out a little more. Now we can find that fractional difference. So let's take the difference. It's going to be the absolute value of the difference of these, so 41.4 minus 25.2. The difference in kinetic energies is, we're going to keep the units absolute here to keep things dandy. So 16.2 meters squared per second squared times that mass of the object. So now we're going to divide by that initial kinetic energy of 41.4 meters squared per second squared times mass. And when we do the division, we get 0.391, right? And there's no units. Why are there no units? Well, look, meters squared cancels. Per second squared cancels. Our multiplied factor of the mass cancels. So it's just a relative proportion between the two, and that's what this value represents. This is telling you that if we were to compare this to another collision using the same formula, we could compare the values and see which one is losing more kinetic energy. And that's what this says. It says, okay, and you could even convert this into a percentage, right? So 0.391 times 100. It's saying that 39% of the energy is lost, right, during the collision. So hopefully that makes sense to you guys. That's the final answer is 0.391. No units on that. It's just telling you to what degree is that collision losing energy. So hope you guys enjoyed. Have a wonderful day.